Hello, my name is Syed Iman Mirzadeh, and today I'm going to introduce the CL Gym Library for Continual Learning. We know that continual learning research is growing very fast, with many new algorithms being introduced every month, and with new research, new challenges arise. So we believe that both researchers and practitioners need a library that can reduce the boilerplate and repeated code for continual learning and has a strong support for various algorithms. And finally, it has a clean and intuitive API for research and development of new ideas. CLGIM includes five main components, and we will discuss each one in details. The architecture of CLGIM is motivated with the philosophy in mind to separate the research code from engineering and experimentation code. First, we introduce the benchmark component. The benchmark component is responsible for managing and loading necessary data for continual learning experiments. For instance, you can see that generic benchmark in CLGIM can load training and validation data for each task, load episodic memory or replay buffer for each task, and also load training data or memory data for several tasks in joint or multitask settings. To give an example of the benchmark API, you can see that CLGIM contains various benchmarks from different domains, including small toy benchmarks that reduces the computation costs of prototyping and testing new ideas. It is also simple to use a benchmark once created, as one can simply use any of the previously introduced methods to load data. The second main component of CLGIM is backbone component, which is a very light weight wrapper around the native PyTorch models and can take care of special cases in continual learning scenarios such as having multiple heads in the output layer. We know that it's also possible to replace this module with native PyTorch NN modules. As an example, we can see an already built backbone such as feed-forward, convolutional, and resonance, or you can use your own created backbones. The third and most important component is the algorithm component, which is responsible for most of the research code. An algorithm component controls many aspects of training, such as backward pass, modifying the optimizer, and creating a private memory for replay buffer. In addition, the algorithm has customizable hooks that can implement customized behavior at different stages of training. For example, we can see a rough implementation of EWC algorithm here, where we use the hook at the end of training task to consolidate the feature information in EWC. In addition, we have customized loss function since we have full control over the forward and backward pass. Finally, the trainer handles most of the boilerplate and non-research code. We can see that the trainer in CLGIM is essentially implements a timeline for continual learning experiments, and it is responsible to design experiment by working with the algorithm component. Here we can see that the basic trainer can train an algorithm in a discussed timeline. In this code, the trainer runs an algorithm for one task, which can include several epochs. And for each epoch, the trainer calls the algorithm training loop in addition to various hooks that can be used for customized experiments. The customized behavior using hooks in trainer is what our final component, the callback, is for. A callback enables CLGIM to be very flexible for different use cases that arises in research. It can listen to several events or only one event in trainer's timeline and implement a customized logic. For instance, in this code, we can see how a callback is implemented for metric collection at the end of each training epoch. Simply, the callback listens to the end of training epoch event that is triggered by the trainer and collects the desired metrics. Then at the end of the learning experiments, the callback can save the metrics to file or report it to an experiment manager. CLGIM includes several callbacks for visualizations, experiment management, model checkpointing, and metric collection. Thank you very much, and please feel free to check out our repository for further information or contact me if you have any questions or comments.